So just as some background on our company, I did have the opportunity to speak with many of you over the last day, but did want to provide some additional background on what we do at Camgen. So we build advanced sensor networking platforms for both the commercial and the government markets. Now, on the government side, we work with the Department of Homeland Security. We also work with the Air Force, the Army, also DARPA, for example, on the research and development side. And over the course of our life, we've made 2 acquisitions. We've acquired Theseus Logic, which, for those in the semiconductor space, was an asynchronous, low-power integrated circuit fabless semiconductor company. And we also bought an engineering division from Cypress Semiconductor about 3 years ago. So through those 2 acquisitions, and plus through some organic growth, we built capabilities in a number of areas in our company, including low-power electronics, analytics, signal processing, software, communications, and networking, all capabilities and technologies that we use in building end-to-end systems. Now, as it relates to our work in the machine-to-machine networking space, we define M2M as simply the marriage of the physical world with the world of computing. And we think that this union will ultimately drive significant operational benefits across a number of different industries and verticals. Now, our specific focus in the machine-to-machine networking market is in an area that I would call sensor-driven decision analytics. And this is the idea of taking sensor data and moving it through the processing chain to deliver business intelligence to clients that help improve their operational efficiency. Now, architecturally speaking, this includes a few components. Number one, low-power electronics and sensor devices that can take physical information, or physical data, if you will, so voltage information from different transducers, and digitize that information. We apply a lot of real-time signal processing to that data. That we then push over some form of a wireless communications network into a cloud-based analytics platform where we can apply various analytical and data visualization tools, and then provide custom reports out to our clients, either in the form to their mobile device or their back office. I will take an opportunity on this slide to mention that yesterday we announced a deal with ThingWorx, with whom we've been working for several months now. We've very much enjoyed our dialogue and work with them, but we are now integrating their software into our cloud-based analytics platform. Now, our product in this market is called Quantus. And Quantus is what I would define as an enterprise end-to-end platform. And basically what I mean by that is a fully integrated platform comprising sensors, communications, data analytics, and custom reporting. Now, Quantus has been designed to address a problem that I think is significant in the end-to-end market, and that is cost of ownership. Basically, our platform allows for high degrees of configurability, both on the sensor end as well as the back end and software, which allows us and enables us to deploy solutions in a very rapid and cost-effective manner. Now, let's look at an example. Seen here is a system, what we call a smart facility system, that we're now working with a large university. This system actually comprises a heterogeneous network of wireless sensors that collect data from different physical systems. So these physical systems include energy consumption within their operations, air quality, for example, vehicle traffic, irrigation and security, and others. And all of this information is processed on a local device where, again, we apply real-time signal processing to that sensor data. We communicate it back into a centralized cloud-based software platform, and then we can report out custom reports to the different operational personnel in the facility. Now, what are the benefits to what I would describe as the enterprise approach? Well, what we've seen in the market today are a lot of what I would describe as point solutions. These are single sensors that communicate some information over wireless communications into some type of dashboard. Our approach is very different in that regard because our system provides a unified view of the sensor. So we do sensor fusion, if you will, in the cloud, and we can take that information again and provide visualization tools and reporting tools, provide custom reports to those clients. It's also flexible and extensible, so once the system's actually deployed within an operation, we can add additional sensors, we can configure new reports, so we can continue to expand the network in a very diverse and heterogeneous way. We can also apply, someone said yesterday they don't like this term, but I'll use it anyway, big data analytics, and that is the ability to do sensor fusion and cross-correlate data between disparate sensors, which we think will deliver a tremendous amount of value in the market long term. And then finally, cloud manage. One of the issues that we see often in the market today, again, going back to the cost of ownership issue, is simply that customers and clients don't want to hire additional IT resources when they deploy these solutions. So we manage everything from the cloud such that the system doesn't have to or doesn't require additional IT support from the organization. Now, we're focused on moving our platform into a variety of different market verticals and industries. These include areas, as I mentioned, smart facilities, as well as logistics, retail, agriculture, manufacturing, oil and gas. I will mention that we're in the process of developing a new large project with an automotive retail organization where we're now rolling out our system into their off-site or their various retail locations to help manage all of their waste oil products. So as they collect waste oil products, they have to store this oil in various tanks on site. And so now we can actually deploy our solution throughout their enterprise to help them get a handle on the amount of oil that they're dealing with and how to logistically and cost-effectively dispose of it. Now, a couple thoughts on 4G. So I'm going to come at 4G from a slightly different perspective. So our design thesis, if you will, when we're building our platform, really revolves around cost of ownership. It's interesting, typically when our salespeople start the process of selling a solution into the market, they start with either an operations person or someone that's technical who gets very excited about machine to machine. A lot of our clients, when we start engaging with them, have never heard of this concept before, but I think after spending some time talking about the benefits of it, they do tend to get excited. But at the end of the sales cycle, and many of you probably have experienced this, you always seem to be sitting across the table from the chief financial officer of the company or the director of finance. And that's the person who ultimately will make the decision whether or not to buy this. And it's interesting, he could care less that you have low power electronics or advanced real-time signal processing or big data analytics. For him, it could be bubble gum and rubber bands on the end of the network. He wants to know about cost of ownership, which is a big issue. So cost of ownership really breaks down into a number of dimensions when deploying end-to-end solutions. Number one is the CapEx expense associated with buying hardware. That's number one. Number two, installation cost. For example, if you're deploying wireless sensors within an operation and it requires one to run AC power and networks, that's a tremendous cost. If you have to put people on an airplane to go out to a site to install end-to-end solutions, also another cost. All of these things start to quickly erode the value proposition of end-to-end. Maintenance costs. So, for example, systems have to run at very low power. So, if they are battery operated, the batteries don't have to be changed every 3 or 4 weeks. They have to last for a couple of years. Another dimension and component to that. So cost of ownership is multidimensional. It's very difficult to deal with, but one has to be very sensitive to that. So as it relates to the communications, if you will, leg of our architecture, there are 4 things that are very important as we consider 4G for these types of technologies. Number one is power consumption. So as I mentioned earlier, we do a lot of signal processing at the device itself. So we try to make very judicious use of the RF communications. If you look at the overall power budget of a solution like this, if one is communicating a lot, it drains the battery in very simple form. So we try to push most of that over on the processing side at the device level so we don't have to spend a lot of time communicating a lot of data over the network. So power consumption of the RF is extremely important. So there are traits there that one has to consider when adopting 4G. And hardware cost. I mentioned also CapEx expenses when selling these types of solutions in the market are critical. If the modem cost or the component cost of 4G is extremely high and continues to drive up that CapEx expense, very difficult, it starts to have an impact on the overall value proposition and sale. I'll also mention airtime cost. Again, that's more of an OpEx, OpEx component. Again, if the airtime cost becomes too high, it starts also to erode the value proposition as well. And then finally, coverage. Coverage is very important. Unlike voice communications, MTM is applied both in large population centers as well as rural areas. So one has to have very good coverage when deploying these kind of solutions. So with that, thank you again for your time. If you have any questions for me outside of the forum or outside of the panel today, please feel free to pull me aside at one of the breaks or send me an email or at this contact information. And thank you very much for your attention. Thank you.